Long before electric motors and automated production lines, the grinding trade of the Bergisches Land relied on water power, stone, and highly specialized manual labor. Grinding workshops, known as Schleifkotten, were typically located in narrow valleys along the tributaries of the Wupper River, where flowing water could drive massive sandstone wheels. As early as the beginning of the 17th century, official mill records already listed numerous grinding sites, showing how central this work was to the regional iron and tool industry. This film documents the transport, installation, and operation of large natural grinding stones, preserving a process that once formed the backbone of blade production in Western Germany. Grinding workshops occupied a key position in the production chain of the Bergische small iron industry. Initially, the heavy stone wheels could only be driven by water power, which limited their location to river valleys and streams. Records from the early 1600s already mention multiple grinding huts along the Moorsback alone, indicating dense industrial activity long before factory buildings existed. A major transformation began at the end of the 19th century with the expansion of railway networks. The opening of the Düsseldorf to Solingen line in 1897 marked a turning point, allowing grinding workshops to use location-independent power sources. New transport routes connected the Bergisches Land directly with Cologne and other industrial regions, simplifying both supply and distribution. By 1900, the tool industry in Remscheid alone operated around 200 grinding stations. Each year, up to 2,000 large grinding stones were required to keep production running. Entire freight trains transported sandstone wheels from the Eifel region until well into the 20th century. The grinding stones were produced in quarries near Neidenbach, close to Kielburg. Special rail wagons carried several large and small stones at once, carefully secured to prevent damage during shunting. Wooden logs inserted through the axle holes stopped the stones from rolling while in transit. Grinding stone dealers acted as intermediaries between quarry workers and grinding workshops. They inspected each stone for correct dimensions, material quality, and transport damage. At any given time, hundreds of stones in different sizes and hardness levels were kept in storage to meet workshop needs. Different tools required different grinding characteristics. Harder stones were needed for sharpening blades, while softer stones were preferred for surface grinding. Saws, shovels, axes, and plane irons all placed specific demands on the grinding surface. By the 1930s, the use of natural sandstone grinding wheels was increasingly restricted. Stone dust caused serious lung diseases, such as silicosis, posing a major health risk to grinders. Although bans were issued early, they only took full effect after 1950, once artificial stones became viable replacements. The transport route leads from the heights of Remscheid down into narrow valley settlements. Many workshops were built on the sites of older water hammers and stream-powered grinding huts. In this facility, saw blades and large cutting tools, such as sugarcane knives, are manufactured. In earlier times, independent grinders worked on a contract basis. In 1923, the company installed its own grinding stations to reduce dependence on external specialists. Grinders were initially employed under a rental system and later became permanent skilled workers. For this demonstration, fir branches from the Eiffel Quarry were included with the stone shipment. They were traditionally used to cushion the impact when lowering the stone into the grinding pit. The dangerous manual installation process, which could take 2 full days, was last performed around 1950. Inside the workshop, older grinding machines stand alongside more modern equipment. The heavily worn stone, reduced to just over 1 meter in diameter, has already been removed. A new sandstone wheel measuring 2.53 meters lies ready beside the grinding pit. The grinding pit is carefully prepared to receive the new stone. Heavy wooden beams are stacked inside the pit to absorb the stone's weight during lowering. The pressure stone above remains in place as it outlasts several grinding wheels. Using steel rollers and long wooden beams, the stone is moved toward the pit. The hammer carpenter supervises each step, checking alignment and balance. Even small positioning errors could cause serious damage during installation. The rear edge of the stone is lifted with a hand winch. As the angle increases, the stone gradually slides forward into the pit under its own weight. Water is poured over the rim to reduce surface hardness and prevent chipping. Once upright, the heavy iron axle is installed through the stone's center. In earlier times, wooden axles made from fresh oak were used, as dry wood could crack the stone when swelling. Metal plates on both sides secure the stone firmly in position. The stone is carefully aligned to prevent side wobble during rotation. Even minor imbalance could reduce grinding quality or cause the stone to shatter. After alignment, bearings are lubricated and the drive pulley is attached. Before regular operation, every new stone undergoes a slow and then full-speed test run. No one is allowed to stand in front of the stone during this phase. Hidden cracks could cause catastrophic failure, a danger that had already claimed many lives in the past. After the test run, the grinding surface must be dressed. Using a long steel tool, uneven areas are removed while the stone rotates at reduced speed. This process produces heavy dust and requires great experience and physical control. Once cleaned, protective plates and splash guards are installed. Water is applied to the stone to cool the grinding surface during operation. The grinding station is now ready for continuous industrial use. Large saw blades are guided between the fast-rotating grinding stone and a slower pressure stone. One worker feeds the blade, while another receives it at the rear. The fine sandstone surface ensures a smooth, even finish across wide steel surfaces. Artificial stones were later tested as replacements. However, they produced excessive heat and rough finishes on large blades. As a result, workshops returned to natural sandstone under special permits. This process shows how precision, risk, and craftsmanship once defined industrial grinding work. Every step required experience, physical strength, and constant attention, long before automated machines took over these tasks. If you enjoy seeing how heavy industry and skilled labor worked before modern automation, you can find more films like this on the channel. Feel free to subscribe and explore further.